some reason. I'm a freelancer working with Java, or I'm a freelancer since 1997. I'm working with Java since 1995, and I have still fun with it. So regardless the popular opinion, Java is no more cool, and there are more cool language. I have really fun with Java, and although I learned the whole time nothing else than Java, I really know only a little. So it's actually a great profession we have, so we can learn the whole life, you know, and go away stupid. Actually, and Java is perfect for that. And I wrote a few books, Rethinking Best Practices. This book explains how to build Java 5 and Java 6 applications without the J2E package, actually. And the next one, it was written because there was lots of requests how to build actually Java 6 applications with Maven 3, Jenkins, and so forth. So I wrote one, and now start with the content. What I actually do in the recent few years, I'm deleting code. So in my Java 5 and Java 6 project, it's really funny, but I just delete incredible amount of code. Actually, if you port a J2E application, Java 6, you can delete at least 60 to 70% of the source code, and of course, many external libraries. In some cases, all libraries. Last year I was in a project we deleted 140 dependent external frameworks and libraries, and no one in the project knew why they are there. But there was no reason except they were coolness reason and so forth. It was everything, which was, I think, in the recent years covered in a popular article or a blog post. So it was like a research project with commercial background. So I think it is a lot harder to build simple applications than build complicated ones, and this is, I think, a problem. In J2E era, you could write an application without thinking about the business logic. So you could say, let's start, with insurance domain. So you can build your business entity, business data transfer object, and a meta, and service locator, and business delegate, and service activator sometimes, application service and session per se. There are about 30 classes without single line of business logic. So it was a perfect, it was actually consultant paradise, right? Because you can start in a project, just write code without any additional value to the end customer for weeks. And these times are over in Java 6, hopefully. So I'm fighting against that, but it's the idea. The first advice what I have in projects has nothing to do with Java 6. Rather than, there is a theory called CAP. Consistency, availability, partition tolerance. And actually what it says is, take 2 of 3. Basically what it says is, if you distribute your application, you can be either consistent or scalable. It's impossible to be distributed, scalable, and consistent. I mean, there's all about trade-offs. This is actually the reason why we have NoSQL databases, right? So for some reason, in J2E projects, and now Java 6, some guys, often architects, believe in distribution. So there is somehow a belief if we distribute our application, it will scale better, which actually doesn't work that way. If you will manage to do that, I suppose you would get a Nobel Prize. So we could stop to developing and just, you know, retire with, I don't know how many meters we'll get, but this is impossible. So my first advice, general advice, don't distribute. If it's possible, just develop everything locally. What I mean is don't distribute the web container and the GB container. Just let the GSF or whatever framework you are using, for instance, Wicked, to access your EJBs and manage these locally without any remoting between. And I don't know why, but there's a common pattern to distribute web container and EJB container. And if I ask why, I get the answer because of scalability, which is absolutely not true. Why I should scale back. Okay? If you have any questions, feel free to ask, and if you find me the break, we can just discuss everything you want to. Or we have night hacking today in the evening, so I can also answer your questions there. J2E patterns in Java E. I thought it's over-engineering, but it isn't. I've recently, actually yesterday, I thought about that, and I found a far better description. It's not over-engineering, it's cargo cult programming. If you know what cargo cult is, there's a Wikipedia definition. It's actually somehow funny and sad at the same time. What it actually means is this. It's a ritual inclusion of code or program structures that serve no real purpose. And I see it a lot in Java 6. The best example is data access object. This is the most theoretical one. If you read the origin definition, I only know one. There's only one definition of data access object by Sun J2E core patterns from 2003. If you read the definition, there is no more purpose right now to use that, because the origin definition was to hide something which is ugly, like JDBC, or be able to write to object-oriented databases, flat files, LDAP at the same time. I never had such a requirement in my project. And if you look at the entity manager, it is even far better. This is something like DAO on steroids. It's actually the origin domain store pattern from J2E core patterns. And I still see data access objects with a single purpose, wrapping the entity manager. They do nothing. They are just empty delegates. If I ask why you are doing that, there is no answer. Because we need decoupling or something like this. And no one pays for decoupling. At least not in my project. I'm not in research, I'm a consultant in European companies. So, and cargo cult programming is not over-engineering. It's something like we did something for 20 years, and now we have to keep doing that. And I suppose it's something like those cargo cult or PowerPoint cult programming. Because on PowerPoint slides, the guys who are drawing the architectures, they need several layers to look nice. You know, they need, I don't know, 550 boxes and transformations. And the problem was with Java 6, you don't need them anymore. You can just build simple pojos, and like it's even needed in Java SE. That's the problem. And it doesn't look nice on Keynote and even PowerPoint. Okay? This sounds funny, but it's a problem. I was asked to draw the architecture in Java 6, so I draw one box, there isn't. It's your architecture, so okay, it's not enough. So, okay, how many boxes you would like to have? I can draw 20, 30, whatever, but I need only one. So, and it's got even better, and this fits perfectly to J2 in Java 6. Like the result of over-applying a design pattern or coding style blindly without understanding the reasons. And this is why I always ask the question, why you are doing that? Why you are doing that? And often there is no answer. It's just because look at the article and look at the blog post, and this is not the answer. So you have to think what you are doing. And if you rethink everything what you are doing, you can delete 70–80% of your code. Okay? Everyone agreed?
So, can I ask a question? Maybe an example of something like getters and setters.
Yeah.
I always tell you, always use getters and setters, always keep the members private.
And is a software question? Because
is that really necessary? I mean,
it's
simpler to deal directly with.
This is my special enemy, I would say. Because if you think about getters and setters in the context of Java 6, they are extremely stupid. Because you have private attribute first because of encapsulation, and then you can click on a button, Control Y and then generate getters and setters, and everything is public. Yeah. But you're still believing it's encapsulated, right? Yeah, yeah. So getters and setters are only necessary in some cases. For instance, in a small application, if you're building JSF apps, it is the easiest way to have data binding. But you can even patch the EL resolver to access private fields. So getters and setters are not really necessary, and they were meant for tooling. Back then there was a beanbox, and there was a tool which we could drag and drop beans and connect them together, and they relied on the existence of getters and setters. Yeah. The next, my special friend also this Java doc. So most of my projects are clean code. I mean, there was nothing to do with Java E. But my favorite recently was every default constructor was commented this is a default constructor. It is the amount of information is actually negative, because if you have, you know, the default constructor, it cannot be something else in Java. It's just a default constructor. And little things like that just pollute the code base and it creates lots of bloat. And this is really hard to explain to non-developers, because like, okay, why comment is bad? It's like, because if you write stupid Java doc, someone has to read that. And if I read two classes with this is a getter, this is a setter, and sometimes it's a toString method, wow, all right, then I will stop reading. And there's a lot of harm. Someone has to write that, but all other guys and girls have to read that. Okay? So that's the problem. So the idea is to verify your design with aliens. Why aliens? Because you could do something like that. So, okay, I'm an unbiased alien, so I'm coming from space, and I have nothing to do with it. Then Java 6, and I learned somehow programming, and then you do something like we do something like service as equals new service input. We have empty delegates. We have one DAO per entity, and we have 50 layers, but 49 are empty, for instance. Then code coverage-driven design, my special friend. In European, German companies, we have something like code coverage of 80%. And if someone forces you, or would force me, to create 80% code coverage, I will just test getters and setters first. This is a very easy job. Nothing can go wrong. Everything is green. So I will, J2E, I could get, I don't know, 20–30% code coverage just with testing getters, setters, and two strings. And the next trend is really, they get 80 with, I don't know, assert coverage of 1%. So there's almost no asserts, and everything is tested with system of println. This is the newest trend I see in projects because, and I asked once why there are no asserts. It's like, because then the build will break, which is logical, okay? So then you say, hey, developer, get explanation for approach, and you ask the alien, is it reasonable? If it isn't, say, developer, please delete code for this approach. If the developer is religious, developer go to vacations and alien will delete the code. This is the source code. It's actually, and this was the vacation. This is actually a social hack. We did it sometimes. We had a really religious architect. And said, okay, you need some vacations and go to skiing or something like that. And he was away, and we deleted everything. And he would come back and say, your idea was brilliant, but the context changed, you know, and so on. Now we saved a lot of time. Even better, I got the idea yesterday. Ask Ruby and Python developer about that. We have 50 layers, but all are empty. It's even better than any. Yeah. It could be more aggressive, but it's also very tough. Ask someone outside the context of your project how it looks like, how your patterns or your approaches look like. So the first, which is actually low-hanging fruit, is start with continuous everything. So I mean, integration with Jenkins or Hudson, I mean, it takes 2 hours. Yeah, I mean, download Jenkins and say Java -jar Hudson or Jenkins.org, and this is actually it runs. And I mean, integration is okay, but also deployment. What I do in Glassfish right now in my projects, I use simple bash scripts to create the whole domain on every commit. It's the same possible with JBoss 7, with WebLogic, with Jython, with Web3 with Jython. Every application server I know is able to provide that. So what we do, we drop the whole domain and recreate the domain in my current project in JBoss, JBoss Glassfish 3.1.1. And JBoss you can do exactly the same. So there's no difference between these different commands, but it behaves like that. Why it's so important? There should be, in my opinion, no difference between source code and configuration. At the end of the day, you need everything in Java EE to run an application, or data sources, or ports, and so forth. So this is first what happens. Automatic deployment and QAs, we use something like Sonar Source, for instance, to find strange things like complex code without code coverage, or even more interesting, very simple code with 100% code coverage. What I also like to delete because there's no reason to test getters and setters, for instance. Really no. In my opinion, it's a defect to testing getters and setters. And if I do a code review, it is a defect. So I delete this test are stupid, for instance. And the last thing are stress testing. Although Java 6 applications are always performing in concurrent way, they are multi-threaded apps. No one tests that, which is actually good for us consultants, but it's very bad for the customer. Because at the end of the day, it never runs as expected. So we get deadlocks, memory leaks, and everything because it was never tested in a concurrent way. So what we do, night jobs. So we start in a Jenkins and JMeter load test, and it tests the whole night. And then in the morning, you will see that it not always runs the whole night because it breaks sometimes in between. So it is a really good exercise to do that. And actually, in the next Java magazine, it's a free Oracle magazine, you will see an article about that. Mocks unit integration and stress testing, what I already said, but what's more interesting, strict separation between unit integration and system tests. What I mean by that, for some reason, we are confusing unit with integration tests. So what I see over and over again in my projects. What does it mean? I always ask, the question is always asked, how to unit test Java 6 applications? And my answer is, there is nothing special with that. So you can just test it like it were POJOs, because unit test does test your business logic and not the infrastructure. So this is the reason, this is the difference between. So unit tests only test only methods, and you rely on mocked out environment. So in my project, we do follow something like the following: we only test complex code with unit test, and simple code isn't tested at all. I know there is a Java conference, and this is a strange opinion because you should test everything and test first and so forth, but I never saw it in real world, except for open source projects, but never for business projects with a real customer behind. So, is someone here who has 100% co-coverage with test first approach in a business project and open source? Someone? Okay. I asked the question whenever I have the opportunity. I never saw a single person say, okay, I'm a business project with 100% or even 90% or 80% coverage with reasonable test and test first approach. So, so there is conference distortion field, I think, in such cases, and real world looks a bit differently. So why is it important? Just because of performance. If you're mocking everything out, your unit tests are really fast. They are lightning fast. And this is really important because if they are slow, no one will commit frequently. In my project, we commit 50, 60 times a day, so it only works in case the Jenkins or Hudson or CI environment is fast. An integration test is something like Archelion, for instance, or embedded Glassfish. So you can boot your embedded database, boot your application server if you like to, but there is a clean separation between both. In case of Maven 3, you have a failsafe plugin, which cares about, we did it yesterday in my workshop, which cares about integration tests. So you only need 4 lines of code to activate that. So just search for failsafe and you will get the plugin. And the Surefire plugin in Maven just cares about unit tests. So you get already the separation out of the box. And the only difference for the developer is unit test ends with test and integration test ends with IT for integration test. Okay? So otherwise, I see also strange patterns like marking tests as fast or slow because of performance, which is really terrible because slow tests are often important and fast tests are not. And if you are short test as well, this is just you cause some damage. But the separation between unit and integration tests works pretty well. Well means in my current project we have several hundred to 1,000 tests and they are executed in seconds because mocks are really fast. And my preferred tool is Mockito, but you can use JMock, EasyMock, whatever. Mockito is the simplest one with the nicest API. Okay, questions? No questions. And XML, in my opinion, is the worst possible thing you can do because operations will never be able to change something without tool support. If you do a mistake, it won't boot. I mean, it's really terrible. If you compare it with database, it's worse than that. So I try to avoid XML. Avoid means not everything, every piece of my application is configured with XML. So I rely fully on conventions. Okay. And what's also important in Java 6, think about the probabilities. So it seems like in J2E era, everything has to be extensible, replaceable, and so forth. But it never happened. So our applications were modular, and we could replace every piece of the application, but there was no requirement for that. And we should learn from this. So in my perspective, this is much better to be more explicit. Say, okay, this relation is hardwired, because it's unlikely that it will change. And this is true maintainability, because if I see another relation to a plugin or something like this, I understand then, okay, this guy won't change in the future, but this guy is just a plugin, and it will change, okay? In J2E era, everything was replaceable, and no one understood the architecture, because, okay, what changes here? And the answer was nothing. Yeah? remember service as equals new service input. If you ask why you are naming the service input, the real reason is because there is no real name for the implementation. You have to have a naming convention because the developer is unable to create a reasonable one because it is forced by architects, patents or whatever to create for everything an artificial interface. In one project I thought already, why not to extend Java-C compiler just to generate interface for everything? That would be the ultimate extension point. You know? I mean, we could build our own DSL and everything extensive was just stupid. You know? So in Java 6, interfaces are public methods are public methods. And if I see an interface in Java 6, we'll come back later, I think about strategy pattern. Someone has already different or multiple algorithms to the same contract, and this is the reason for having an interface. And everything else is just dependency between classes. Agree? Okay.
Well, how do you do good unit testing with mocking if you don't have interfaces?
Oh, we did it yesterday. Interfaces are harmful actually. If you would like to mock out classes, it just works perfectly with any framework you use. In the last 5 years, there's no more problems. Should I show you at the night hacking session?
Okay.
Okay. So remember me, I will show you how to mock out classes without interfaces. Or if not, after the session, but I'll show you that. Okay? We did it yesterday, and I sent it to the organizer. Just the code is already checking. So the answer is you don't need interfaces to mock out. With Mockito and other frameworks don't care about interfaces. In fact, there is even PowerMock. It's an extension of Mockito. You can mock out static classes and static methods and so forth. So there are no limits. Okay, but these are very common questions, so thank you for that. What also funny, in some projects they used interfaces just to test everything, and I did a code review, and there are no tests. So right now someone would like to have interfaces for testing, and it's okay, but I will come later in 1 year. I would like to see the tests. Okay, and this is a really common misconception, just to be able to test, but then you have to test. Homegrown frameworks are dead, except they have some business meaning. But and this is, I don't know. This year several times we started a Java 6 project with external consultants. I was one of them, and they expected me to build a framework together, infrastructure, configuration, logging, and I said, okay, look, we don't need anything. We have Java 6. I mean, we could build that. It's a funny job, but I have no use case for that. And neither the customer nor the companies were prepared for that. So I couldn't stand it. So okay, I go away for 6 weeks. But I came back and the whole team built something, which we deleted afterwards because it could be replaced by CDI, EGB, and everything else. So if you start a Java 6 project, pick the first use case and start with the use case. There is no room for frameworks, infrastructure, and all the strange things. You will find yourself by reinventing the wheel or re-implementing parts of Java 6. I see it over and over again, and it's a huge difference in J2. In J2 you could build your MDA tools and patterns and generators and builds. In Java 6 everything is standardized. There is no reason to build something homegrown. And everything you build inside your company, it affects your maintainability in a negative way. Okay? So just start with the business logic. And in my case, not even the business department knew the use cases. You knew the use cases now, yeah, of course, we started today. We're starting today. Oh no, we thought you will build your infrastructure. Okay, we have it. Okay? Javadoc is suspicious, as I already said. Getter setters, you should delete all Javadoc and only document things which are not obvious. Simple advice. And everything which is obvious is forbidden. So, I mean, that's nothing to do with Java 6, it's just common sense, but I see a lot of, all my favorites. There is a Javadoc marker like, here attribute starts, attribute ends. Method starts, method ends. So, okay, it's just usually in Java that we have attributes and method, you know, but there is a huge comment. Now the attribute starts, and crazy. In one project, they even create Eclipse and Netbeans templates to be able to generate the markers with control space or something. Okay, nice. Dry and die, don't repeat yourself, and the application is evil. This is die. The application is evil. It was stolen from Ruby, Python, and the other guys. I mean, in every Java 6 project, for some reason, developers are maintaining parallel object hierarchies. What it means, we have JPA entities, nothing wrong with that, and parallel to that, they have exactly the same DTOs, exactly the same. And recently, they built mappers It's a huge effort, you know, to deeply clone all the hierarchy. And there is no test for the mapper, of course, because it's boring to test the mapper, which on the one side it invokes get, and on the other side set. There's get set, get set, get set. And I asked them why you are doing that, and the answer was because of decoupling. So I looked at the project history. It runs already for 2-3 years. There's not a single case of difference between both. So we are really believing that in the next 5 years there will be a difference. If it really is, I would just cover the difference, you know, not the common case. It seems like in your project the common case is identical object hierarchies. I mean, if you have deviation from that, I will just cover the deviation. For this particular case, I will create a detail for you. So then I get comments like, yes, but if we expose JPA entities to the client, I have to expose JPA annotations as well. Like, wow, 5 kilobytes. We are talking about 5 to 10 kilobytes. And this kilobytes won't probably change in JPA 2 or JPA 3 or whatever. Okay. So even that, we're talking really about 5 kilobytes. From pragmatic point of view, I don't care. From the robustness point of view, it's as far less likely that JPA will change before your business logic changes, right? I mean, Java 7 will come next year. Even if this changes, you have to roll out everything. So I mean, there is no real reason to encapsulate. This is a huge effort. I think in this project, they spent weeks, if not months, just copying objects back and forth. And they believe that they increase the maintainability with that. Okay. Back to Java SE thinking. I mean, also yesterday in my workshop I was asking the question, how many annotations do we need to know? And the answer is about 6 to start with Java 6 to build a Twitter, Facebook, or something like that. Facebook probably not, but Twitter. Yeah? And I mean, and this is really think in business terms, not in Java 6 world, because Java 6 should help you, and this is not the case that you have to read 50 books to build a simple application. What it also means, back to rich domain objects. So anemic domain objects were anti-pattern since 2003. Martin Fowler wrote a post in his enterprise patterns book. He said, okay, anemic objects are very common anti-pattern. Why? No one knows. And that's really true. What it means, nothing against writing business logic in JPA entities. They can be real objects. And this is against some best practices in many companies. If I ask why you are against having business logic in domain entities, I never got a real answer. And I know from where it comes, because in the year 2001 there were some courses teaching patterns with CMP, Container Managed Persistence, 1.0 and 2.0. This is a very old technology. And at that time it was not reasonable to put business logic to CMP to entities. There was no inheritance. It was intrusive. You have to implement each below store and strange methods like that. So it was a good practice back then to separate your domain objects from the persistence. But right now, you can in one project we just reused already existing rich domain object graph and make it persistent afterwards with JPA perfectly. Okay, but this is anemic domain object, in my opinion, is anti-pattern. If the logic fits, you should put the logic inside an entity, and you can save a lot of code. Otherwise, you have homework, go to antiifcampaign.com. It is if you have too many if-else statements with type distinction is no more maintainable. You can delete these statements usually with inheritance, but it's nothing new. It's like what we learned in the school, right? Inheritance can help you. So, but we forgot about that in the 10 years of J2E. So, no interfaces. In all migration projects, we deleted all interfaces. This was hard because something like, yeah, you are destroying our beautiful layers and we have no encapsulation and so forth. But the interesting point is we are able to accomplish that, which is strange. It means there was no case where interface was implemented by two classes. So the interfaces were pointless in the project. So there was no real strategy pattern in the project. It was just, you know, empty layers. So, and then we introduced interfaces on demand. And I was, oh, this is hard to do it afterwards. If you think about this, it's about 30 seconds task. With every modern IDE, extract interface. And it will replace all occurrences of the reference by the interface. So in worst case, you will lose about 1 minute. introduce an interface afterwards. But what we are doing instead, we are building interface for everything. And I mean, it was reasonable back then. Before year 2000, we had no refactoring in Java. You have to remember that. And J2E is older than that. And at that time, it was really reasonable to build interface for everything because refactoring was hard. Since 2001, Eclipse is perfect refactoring tool, and since then, every other IDE is very good in refactoring. Okay? So, no interfaces means interfaces on demand. Good interfaces where something varies. And don't use interfaces as general pattern because you cannot explain it to anyone, neither to an alien nor to a Ruby developer. So there is, this is not explainable. Agreed? Except we are building public APIs like JDBC or JMS, but we are not building something like that usually in business projects. But if you're building an API like that, you need interfaces, of course. Okay? Otherwise, you won't be able to replace the classes. But I mean, no one builds such a thing. No one. Not all of us building JDBC APIs. Okay?
Cyclic dependencies are not bad. Cyclic dependencies.
Cyclic dependencies are not bad. They are bad, but if you prohibit cyclic dependencies, what will happen? The developers will move classes to packages with meaningless names, like domain, data, model, very common, and you will end up with packages with no cyclic dependencies, huge packages, and you will find everything in the package. By the way, in my projects, names like commons, utils, infrastructure, core, base are forbidden. Because if you start with such a name, you will find everything. It's like kitchen sink. Call it kitchen sink is the same thing. How to evaluate that? Because I don't have it on slide, but it's a very good question. What I do, I go with Subversion in a tool like Crucible or the IDE to a common, and then click on the common class, which is supposed to be common, and click and say find usages. And you track back who uses actually the class. In 99% of all cases, only the developer who created the class. And then you can delete the whole page. Because, okay, take the class back to your module and there's also a module disease. It's also very common in Java 6. Especially hard if someone moves from ARMS to Maven. In some project we talked about yesterday, we had 500 modules in Maven. And in some modules there were 3 classes in one module, with the hope someone could find that interesting. And interesting, it is interesting, but useful. So modules, there should be a use case for modules. It's not that we should discuss everything, but be reasonable about that. No extensive layering. So there is no layer because it is in Java 6. You think about this. View annotations, you get persistent class, and this class has already business logic. It's really hard to find a better abstraction than this. If you are building embedded software, it's probably a different case because you have to interact with the bus or whatever, which is really labor intensive. But in Java 6, everything already works out of the box. You are able to create with 3 classes CRUD applications, without any plumbing. This is the problem. The plumbing is gone. So there is no need to encapsulate something. So if you rethink the gang of 4 patterns, factory is absolutely dead in Java 6. We have dependency injection. What we did yesterday, we tried to integrate a legacy poacher with strange constructor. It can be achieved with a simple annotation called produces. I will show you tonight how it works. With add produces, it is able to create whatever you want. So you have a hook afterwards. So you can provide a class. If the result type matches with simple produces, you are able to create the class. What it means, there is no need for factories up front. They are dead. You can introduce factories on demand. Okay. Observer, the same story. Observable, you have to maintain your listeners. In Java 6, you can inject an event, and you can, on each part, every parameter you would like to, you can mark or denote the parameter with observes, and the event gets delivered for you. There is no plumbing on your side. It just happens. It's called observes, and this actually kills GMS topics for local delivery. So we are able in Java 6 to replace GMS topics for local eventing. Builder pattern is a revival of builder. We use Gang of 4 builder to create consistent JPA entities. If they have business logic, you can use builder to create JPA entities nicely. with meaningful methods. Instead of default constructor and getters and setters, you can apply builder pattern to create something like conference with attendees and speaker create. Instead of new conference, set speaker, new, set speaker, and so forth, right? So just the old builder pattern becomes meaningful again in Java 6. Facade pattern, I mean, as I already said, there is not much to facade except the first layer. Application service is a good idea to have one facade, but you shouldn't have multiple facades in the projects. It is really hard to imagine what you would like to encapsulate in a standard business project. Bridge. Bridge is nice. What it means, you can replace at once a whole product hierarchy. This is like the classic example is like Swing. If Swing is running on Windows, in Windows peers and on Motive or Unix Motive peers, on Mac peers. And to achieve that with Java 6 is actually really simple. What you can do, there are stereotypes, and you create stereotypes with name of your choice. Let's say Windows and Motive or Windows and Mac. And then if you annotate these stereotypes with alternative, you will deactivate all objects. They are now visible by the application server. The cool thing is, with a single entry in bin6ml, the name of the stereotype, you can reactivate everything at once. So, use case, if you are building, my classic example is content management system, and you would like to activate JDBC storage, LDAP storage, or file storage at once, you can do that. We use it in business projects sometimes to configure customer-dependent things. Yeah. Okay. Bridge. Strategy pattern is nothing else than an interface with implementation. If you get two implementation, your server your application becomes undeployable. You get ambiguous dependencies error. What you have to do, you have to configure application with annotations called qualifier, which is really nice. You name the qualifiers by business responsibilities, not by technical terms, and you can configure application that way. You can say, for instance, interface encryption, and you have AES and other encryption, and then you can say you can invent your own qualifier. You could create your own qualifier with the name encryption level, strong and weak, for instance. Okay, and then we'll choose the AES encryption or something else. Or if you need a plugins with Java 6, what you can do, instead of using service loader, you can just inject the interface, grab the interface with instance, and search for all occurrences of the implementation on the fly. So even, I mean, this is something like mix of chain of responsibility pattern and plugin you get for free with one single annotation. Decorator, I mean, there is even one decorator in Java 6. We have interceptors and decorators. Interceptors are generic, so it's like AOP. So you can put before every method call, and you can intercept all methods calls, and on top of that, you can decorate. And what a decorator is like decorator pattern is classic thing for decorator. It works like that. You have interface and implementation. You can tell the application server just decorate each calls with my class. This is classic decorator pattern like in Java O package without any pumping. So what it happens, the container injects your decorator instead of the real class. So there is no constructor involved, there's no onion. You know, the onion is created by the application server. And the one feasible pattern I know in Java 6 is entity control boundaries. This is the old pattern from agile modeling. What this pattern does, I structure my applications that way, that I have only business components, which in fact are packages with business names. And each package is structured that way that I have boundary, is the entry point, controllers are optional, and entities is the persistence. Why I'm doing that? Because you can measure dependencies a lot better with that. And if Jigsaw will come out, or you would like to use OSGI, everything is package-based. So with Jigsaw, JDK 1.8 or OSGI, you can say, I only would like to expose boundary, but hide control and entity, it only works in packages. And with tools like JDepend or Sonar source, what I can do, I can measure dependencies and say, it is not allowed that an entity accesses control and control accesses boundary, only this direction is allowed. Okay? So I actually wanted to hack some code for you, but we have no more time, so I will do it today evening without any slides, promised. So if you have questions, just ask now or write down, and I will try to show you at the evening. So if you would like to see stereotypes, producers, whatever, as I said, we can cover it. We have, I think it's a whole night. Okay. So questions?
But what about the last slide? So you would expose, you would create a boundary, but that boundary would expose, I guess, entities themselves. And if these entities are rich domain objects, who can do whatever they want. If you expose that on your boundary, then some other applications can actually.
Yeah, it's a good point. What he says, my boundaries could expose JP entities. It's true. And he said then some other applications can call business logic on JP entities. So, okay, this would be strange because if I have rich domain objects and I have a boundary and I expose the rich domain object, what I do then is I keep the JPA entities managed or attached, and they can be manipulated directly by JSF or Wicket or something. They have not a problem. But a mix is problematic if you detach the entities and send the entities to an external client. It's a problem. But what I have to say for that is, in 80% of all my Java 6 applications, I think even in every Java 6 application, we use REST as the communication protocol. And then your JPA entities will be serialized over XML or JSON anyway, and you get a real decoupling. And SOAP will work out as well. SOAP is also okay. From the programmer point of view, it's just nice, but it's not so nice for the clients we are using it also. But from your perspective, it's just one annotation, what service, what method you are done. Okay? So if you would like to have a remote interface with add remote in EGP, you have to expose probably DTOs.
Yeah, or
use Hessian or something like that.
Just get it there.
So that don't use add remote alone. Other questions? Everyone agreed. I mean, there was a most theoretical session, I think I gave, so everyone agreed. Yeah.
Is it feasible to use the interface on demand pattern in an OSGI environment?
Is it feasible to use OSGI? Really? It's really a good question. The problem with OSGI is it relies on interfaces. The problem with my business projects is I have lots of relations between business objects and not so many relations between services. So in most of my business projects, OSGI is not feasible really, because what happens then, if I have two business components, and if I have entities in different business components, and I have two OSGI bundles, right? I have to prohibit joins between components, which is crazy. You know? So in this environment, OSGI is not feasible. OSGI is feasible if you're building application servers, IDEs, or something like Photoshop or something. And I would only use OSGI in case if you read the business or if you talk to the business person, you already see the plugins. You know what I mean? If you would discuss a Photoshop or something similar, we would talk about filters and transformers and stuff like that. It's nothing else than plugin. And the plugin interface is already given. Like, here is your image source, and I give the image back. In my business project, no one can imagine the interface of a service, of a plugin, and then OSGI is not feasible, really not. You know what I mean? So
Thanks.
thank you. Great question. Thank you very much. And see you